Hi everyone, welcome to Numeriq Learning. So in today's Do Math With Me daily practice series for 20 minutes, this is going to be a regular practice wherein I will be solving say 5 or 6 questions which will take approximately 20 minutes of your time. So during this time, before we start, I want all of you to take a notebook and a pen and solve with me. I will give you time to solve so that it's easier for you to understand as well and solve it real time. The first question of today is square root of 0.4. You are asked if it is a natural number or is it an integer, is it a rational number or is it an irrational number? A 1 mark question. Okay, so let's do it. Now if you take, let me give you a few seconds. So what would you do here? You are given square root of 0.4. So what can you write 0.4 as? Can you write it as 4 divided by 10? Yes. So try with that. That's a hint for you. You can write 0.4 as 4 by 10. So let me do it for you. So square root of 0.4, you can write it as square root of 4 by 10. Right? This can be written as square root of 4 divided by square root of 10, which is nothing but 2 divided by square root of 10. Right? So 2 is a rational number and square root of 10, it's an irrational number. Right? Rational by irrational is always irrational. Okay, so the correct answer is D, irrational number. Always remember, whenever you have a square root and a number which is not a perfect square, for example, if you take a perfect square root of 4, 4 is a perfect square, it's square of 2, isn't it? 2 square is 4, so square root of 4 will be 2. But if you take square root of 5, 5 is not a perfect square, not a perfect square, so it is irrational. Okay, always remember, whenever you have root of not a perfect square, a number which is not a perfect square, it is irrational. It is always irrational. Okay, so similarly we got here square root of 4. 4 is a perfect square, so you wrote it as 2. 2 is rational. However, the denominator had root of 10. 10 is not a perfect square, so root of 10 is irrational. So rational over irrational is always irrational. Okay, so this is another point to remember. Whenever you have a rational number and whenever you have an irrational number, irrespective of whether you add them or you subtract them or you find the product or you divide them, it is always going to be irrational. Okay, so this was the first question. I hope you solved it almost instantly as soon as I told you the hint. Right? So this was the first question of today. Let's move on to the second question. A very easy question. So this is one of the topic which is very important. You have to prove that 7 minus 3 root 5 is an irrational number given that root 5 is irrational. A very easy problem. Okay. If you know it, please pause the video and you can do it. And then later on check if your answer is matching with mine. Right? You can pause the video here. Meanwhile, for those who do not know how to solve or for those who have not been taught how to solve, let me do it for you. So whenever you have to prove something is irrational, you have to use a contradiction method, a contradictory method. So here we will assume which is something contrary to what is asked. So we'll say you have to prove that 7 minus 3 root 5 is irrational. So we will assume that it is rational first. So let us assume that 7 minus 3 root 5, let it be rational. That's your first step. Right? So 7 minus 3 root 5. What do you mean by rational? Anything which can be written in the form of P by Q, where P and Q are both integers. P and Q are both integers and q is not equal to 0. So this is the definition for a rational number. What is a rational number? Any number which can be written in the form of p by q, where p and q are both integers and q is not equal to 0. Okay. Now, we see here you have a rational number, real number, right? Rational number. Here you have a rational number multiplied by an irrational number. Root 5 is irrational. So what can we do is, we will take minus 3 root 5 to one side, make it plus 3 root 5, and p by q we can take it to the left hand side. So let us rearrange it. So you'll have 3 root 5 is equal to 7 minus p by q. Okay, so we have rearranged it in a way that the term that contains the irrational part, it is in the left hand side. All the other terms, let's take it to the right hand side. So this will become, the LCM is q, so you have 7q minus p. On the left hand side you have 3 root 5. Let root 5 alone remain because root 5 is irrational. 3, let us take it to the denominator. So 7q minus p divided by 3q. Right? This 3 goes to the denominator. You just cross multiply it. Now, if you see here, p and q are both integers. So integer into integer is integer. Okay, so here everything is an integer. Integer minus integer is integer divided by integer. So all of these are, this is a rational number. Okay, this is rational. However, root 5, this is irrational. And we can very well say an irrational number can never be equal to rational. So this makes our assumption wrong. You have to definitely write the statement that, therefore, this makes our assumption wrong. What we assumed was wrong. What did we assume? We assumed that 7 minus 3 root 5 is rational. So this assumption happened to be wrong. Therefore, 7 minus 3 root 5 is an irrational number. Is an irrational number. Hence proved. You have to prove it, right? The question is, so you'll write hence proved. Okay. So there you get your 3 marks. If it is a 3-mark question, you will get 3 marks. See, you are already given that root 5 is irrational. So root 5 is irrational. Everything else on the right hand side. Okay, so I hope you understood. Any question of this format, you have to make sure you make it, first of all, you assume it something which is a contradictory statement. You assume that it is rational and then go ahead with stating that a rational number should be in the form of p by q, where p and q are integers and q is not equal to 0. Keep the term which has got the irrational part on left hand side and everything else on the right hand side. This is how we go ahead and do it. So now let's move on to the next question, wherein the next question is also of the same type. The question is, prove that root 2 plus root 3 the whole square is an irrational number given that root 6 is irrational. So let us do it the same way as we did the second question. The method is called the contradiction method. We will assume that let root 2 plus root 3 the whole square is rational. Okay, which means root 2 plus root 3 the whole square is nothing but it is of the form p by q, where p and q are integers. Where p and q are integers and q is not equal to 0. Right, the same way. Now let us expand and open the bracket, solve for using a plus b the whole square. So it is a square plus b square plus 2ab. 2 into root 2 into root 3 equal to P by Q. We did not do anything. We just opened the bracket and we solved it. Now let us solve here. Yeah, the left hand side. Root 2 the whole square is 2 plus 3 plus 2 root 2 into root 3 is root 6 equal to P by Q. Again, let us retain this term in the left hand side. 2 root 6 equal to, let's take everything else onto the right side. So 2 plus 3 is 5. When it goes to the right side, it becomes minus 5. So this is equal to LCM cube P minus 5Q. Here you have 2 root 6. So root 6 equal to P minus 5Q divided by 2Q. So what do you say? This is rational. The right hand side you have a rational number and here you have an irrational number. Okay, and irrational, I'm going to write it here. So irrational cannot be equal to rational number. Therefore, this makes our assumption wrong. This makes our assumption wrong. What was our assumption? We assumed that root 2 plus root 3 the whole square is rational. So it turned out that our assumption was wrong. Therefore, root 2 plus root 3 the whole square is an irrational number. Irrational number. Okay. So such questions are very, very important with respect to chapter 1. Okay. So please make sure it is not sufficient if you just prove or show the examiner or the evaluator that irrational is not equal to rational. You have to write this statement carries a huge value to show initially to assume a contradictory statement and then later on to conclude that this makes our assumption wrong. Therefore, the given number is an irrational number. So very, very important that you get into the practice of writing these statements which carry marks. Okay, so I hope you understood. Let me know in the comments if you're finding my video really useful, and if you have any suggestions or feedbacks with respect to my class or the questions or the way I explain, please feel free to post that in the comments as well. Okay, let's move on to the next question. Yeah. Find the largest possible positive integer that divides 125, 162 and 259, leaving the remainder 5, 6 and 7 respectively. So you have to find the largest possible positive integer that divides a number. And what is that number? You will get that number when you subtract the given number, this number minus the respective remainder. So let us do that in the first place. So whenever you get questions wherein you are seeing these lines, right? Wherever you have given a condition, that is numbers leaving the remainder, immediately the first thing to do is get the actual number. And how will you get the actual number? By subtracting, say 125 is here, you have 162 and 259. But these are not actual numbers. You will get the actual numbers if you subtract these numbers from its respective remainders. So let us do that. 125 minus 5, 162 minus 6, 259 minus 7. Okay. So 125 minus 5 is 120. 162 minus 6, it's 156. 259 minus 7, it's 252. Now these are the actual numbers. These are the actual numbers that you need. Okay, so you have to find the largest possible positive integer that can divide these three actual numbers. Okay, so what is the process to find? It is nothing but, so you cannot have a number which is bigger than 120, 252 to divide these two, right? So you need a value which is lesser than these value. so that that smaller number can divide these three. So remember that the required answer here, the answer that you need is lesser than the given these three numbers. So it is always going to be your HCF. You have to find the HCF of 120, the actual numbers 156 and 252. Okay, so let's do the prime factorization of 120. Start with the lowest prime number 2, 2 6 are 12, 0, again 2, 30, again 2, 15, and then 3 and 5. Okay, so for 156, start with 2, 2 7s are 14, 2 8s are 16, again 2, 3s are 6, 9, again 3, 13. Okay, so 252, again start with 2, and then 2 2s are 4, 2 6 are again 2 6 are 12, 2 3s are 6, and then 3 2 1, again 3 7. 7 is a prime number. Okay, so what is the prime factorization? Let me write it in a proper form. 120 is equal to 2 cube multiplied by 3 multiplied by 5, right? 156 is nothing but 2 square multiplied by 3 multiplied by 13. And 252 is equal to 2 square multiplied by 3 square multiplied by 7. Okay. So this is the prime factorization of the three given numbers. Now let me just erase this so that I have space to write. I hope you are also doing along with me. Okay, so these questions are the most frequently asked questions in all the exams, irrespective whether it's board exam or pre-board or your internals. Okay, so here now we have got the three numbers. So for HCF, what will you do? You will be finding the lowest power of all the common factors. But before we find the lowest power of common factor, let us make it common. So 2 is common, right? 2 as a prime factor is common across the 3. 3 is also common. 5, you have it in 120, you don't have it. So I'm going to put into 5 raised to the power 0 into 5 raised to the power 0. 13 is not here, so 13 to the power 0 and 13 to the power 0. Here you don't have 7, so 7 to the power 0, 7 to the power 0. I'm just making sure that I have common factors in all the three numbers. Now let me take the HCF. HCF is nothing but for all the common factors, you have to take the lowest power. Lowest power. Okay. So for 2, what is the lowest power? It is 2 square. For 3, what is the lowest power? It's 3 to the power 1. So it's just 3. For 5, the lowest power is, here you have 5 to the power 1. However, you have 5 to the power 0. So 5 to the power 0 is the lowest power. For 7, it is 7 to the power 0. And for 13 also 13 to the power 0. All these are equal to 1. Right? So 2 square 4. 4 into 3, 12. So what do you get? The required number is 12. Okay. The required number is nothing but 12. So 12 is the largest positive integer that can divide 120, 156 and 252 without leaving a remainder. That means 12 can divide all these three actual numbers perfectly. However, if you divide 125 by 12, it will leave a remainder 5. If you divide 162 divided by 12, it will leave a remainder 6. 259 divided by 12, it will leave a remainder 7. However, 12 is perfectly divisible for all these three numbers. Okay, so that is one of the most frequently asked questions. Now, let us move on to the last question of the day. That is, if HCF of a very important question which has already been asked in the previous boards. Let's go ahead. So, if HCF of 85 and 238 is expressible in the form of 85m minus 238, find the value of m. So, you are given the HCF of the two numbers is expressed in the form of 85m minus 238. So, first of all, let us find what is the HCF of 85 and 238. So, 85, let's do the prime factorization. 85, start with 5. So 5 ones are 5, 5 sevens are 35. 17 is a prime number. And then 238. Start from the lowest prime number 2. 2 ones are 2. Again 2 ones are 2. 2 nines are. And then 3 will not go. Let's try with 7. So 7 ones are 7. 49. 7 sevens are 49. So 17. 85 can be written as 5 multiplied by 17. And 238 can be written as 2 multiplied by 7 multiplied by 17. I am going to make the factors equal. So here I'll write 2 to the power 0 and here I'll write 7 to the power 0. However, here you will have 2, you have 5, 17 and 5 to the power 0. Just making sure you have common factors. And now the HCF is equal to, take the lowest power of all the common factors. So for 2, the lowest power is 0. For 5, the lowest power is 0. For 7, again, the lowest power is 0. And for 17, it is same. So the HCF is nothing but 17. Okay. So what is given? So if the HCF of 85 and 238, which is 17, is expressible in the form of, which means if 17 is equal to 85m minus 238, find m. So we can have 85m is equal to 17 plus 238. What is 238 plus 17? 14, 15, 5, 1, 3, 4, 5. So 255, 255. Here you have 85m. So m is equal to 255 divided by 85. 85 into 3. Okay, it's 255. So the value of m that you are getting is 3. Okay, so these kind of questions are very, very important. Make sure you pause the video and do it. And if you have any doubts, please do post it in the comments. And I hope my videos are useful. Let us try to practice sums from all the topics, one topic a day or one chapter a day, and questions that are very important, that are frequently asked, or questions that are new of a different kind. Make sure we spend 20 minutes a day, and this practice will take you a long way to get a very high score and boost your confidence. Hope this practice will definitely be helpful. If you like my video, please do like, do share, and please do subscribe. Thank you. Happy learning.